This is the second video in the Crash Course Trigonometry series. In this video, we're going to go through different ways of measuring angles. So what does it mean to measure an angle? Well, when we measure the distance between 2 points, we use units like meters, feet, miles, kilometers, etc. But we can't use those kinds of units to measure rotations. So we need to come up with a different way to do it. But what it would mean to measure an angle would be to tell us how much of a rotation is represented by that angle. Probably the most intuitive way to think about rotations is to think about them in terms of revolutions. So one revolution means one full rotation around that you're returning to the same orientation. So many angles will be fractions of that single revolution. You could think of half a revolution, a quarter of a revolution, and so on. But other angles might be multiple revolutions if you're spinning around multiple times. Also remember that by convention, we established this in the previous video, by convention, negative angle measures represent clockwise rotation and positive rotations are counterclockwise. So let's take a look at a couple of rotations and see if we can understand how many revolutions they represent. For this first one, we notice that, again, our angles are in standard position, so the initial side of the angle is pointing along the positive x-axis. And what we see here is that we're doing one full rotation in the clockwise direction. So we call this one revolution. We're spinning around in a circle exactly once, returning to the exact same orientation that we started with, so we're going around the circle one full revolution. For this next picture, again, we're rotating counterclockwise. We can estimate the rotation that we're seeing in the picture here by thinking to ourselves, well, a quarter of a rotation, that would be 1/4 of the way around the circle. That would be what we'd have here, 1/4 revolution. A half of a revolution would be all the way around to here. So what we're seeing here is somewhere in between that. We're in between 1/4 and 1/2. And in fact, what this represents is 1/3 of a revolution. So one drawback, as you might already be seeing, of using revolutions is that, again, many of the angles that we would want to consider would involve fractions. So that makes our lives a little bit more difficult. What we see here in this final picture is a clockwise rotation, and it's, again, going halfway around the circle. So in this case, this angle represents -1/2 of a revolution. Again, the negative there indicating that we're going in the clockwise direction. A more common way of measuring angles is by using degrees. And this is probably familiar to many of you. One full revolution here is represented by 360 degrees, which will sometimes write out the word degrees, or sometimes we'll use this little circle symbol. And then again, that's not a 0, right? So that's not the number 3600, that's 360, and then the degree symbol that we see there. And if that number 360 seems a little strange to you, it's actually for historical reasons. The ancient Phoenicians used a number system that was based on the number 60, and they really were innovators of navigation tools, and a lot of those tools are precursors to what we think of in the modern day as trigonometry. So how do revolutions and degrees relate to each other? Well, one revolution is 360 degrees. So this gives us a way of converting between revolutions and degrees. Let's go back and look at those angles that we looked at before and see how we can convert them from the revolutions that we figured out to degrees. Okay, so remember this first picture was one revolution, and we know that one revolution is exactly 360 degrees. So one revolution equals 360 degrees. In this next picture, we had 1/3 of a revolution. So that's going to represent 1/3 of 360 degrees, which is going to be 120 degrees. In this final picture, we had -1/2 of a revolution, and so that will represent -1/2 of 360 degrees, and so that will be -180 degrees. So going from revolutions to degrees is just as easy as multiplying the number of revolutions by 360. If you want to go backwards, if you want to go from degrees to revolutions, you would just have to divide by 360. You would have to do the opposite operation, and that would get you back to revolutions. So pretty easy to go back and forth between revolutions and degrees. Now there's a third common way of measuring angles, and that's using radians. To understand what a radian is, what we want to do is try to go back to that initial point that I made at the beginning of the video, where we said that we can't use meters, feet, miles, etc. We can't use distance units to measure angles. But in a way we can. So what we can think of is when we look at a circle with radius 1, so the distance from the center of the circle to the edge of the circle is 1 unit. And what we're looking for is an angle, a rotation, that corresponds to 1 unit walking along the outside of the circle. If we can find that rotation, then we call that 1 radian. And it turns out to be approximately 57 degrees, but we're going to get back to the exact conversion rate a little bit later. But there is a rotation where on a circle of radius 1, that gives us a distance of 1 around the outside. But now let's make the angle different. If we make the angle bigger, so if we have an angle of theta radians, then the distance around the outside of the circle will be theta feet, meters, kilometers, etc., whatever distance units we're using. So the angle measured in radians tells us exactly the distance around the outside of the circle. So that's the usefulness of radians. But what if our circle doesn't have radius 1? Well, if our circle has radius r, then the distance around the outside of the circle is r times theta, where again, theta is the measure of the angle in radians. And again, we're using the Greek letter theta here. It's really common for us to be using Greek letters to represent angles. You might not be too familiar with the Greek alphabet here, but this symbol here, which kind of looks like a 0 with a horizontal line going through it, that is the Greek letter theta. So that is something that we'll be seeing fairly frequently. But this gives us an arc length formula. So this tells us that if you have a circle of radius r and an angle measuring theta radians, then the distance around the outside of the circle is just r times theta. And there isn't as easy of a relationship between the angle measure and the arc length when the angle is measured in either revolutions or in degrees. So this is one of the reasons why radians are a useful thing for us to consider, because it makes it relatively easy to relate the measure of the angle in a circle to the distance around the outside of the circle. Okay, so how many radians are there in a full revolution? So in other words, if we wanted to convert between revolutions and radians, what would that be? Well, if we go all the way around the circle, right? So here's my circle with radius r, and I do my rotation where I go all the way around. I do 1 full revolution. Well, what I know is that the distance around the outside of the circle is the circumference of the circle. So that's 2 pi r. But I also know that that's r times theta, where theta is this revolution measured in radians. So if 2 pi r has to equal r theta, then theta has to be 2 pi. So 1 revolution corresponds to 2 pi radians. So that gives us a conversion. And that also lets us convert between degrees and radians, because we already knew that 1 revolution was 360 degrees. And so that means that 360 degrees equals 2 pi radians. So if we take that equation and divide both sides by 360, that tells us that 1 degree, right, if we divide by 360 here, then 1 degree is going to equal 2 pi divided by 360, which reduces to pi over 180 radians. If instead we take both sides of that equation and divide both sides by 2 pi, then that tells us that 1 radian equals 360 over 2 pi, which reduces to 180 over pi, that many degrees. And as I said earlier, that works out to be approximately 57. So it tells us that 1 radian is around 57 degrees. We really do want to try to keep things exact when we can, so we will just use 180 over pi. All right, let's work through some sample problems where we convert between radians, degrees, and revolutions. So for this first one, we're being asked to convert pi over 4 radians to degrees. And what we learned on the previous slide is that 1 radian is equal to 180 divided by pi degrees. And so that means that if we have pi over 4 radians, all we're doing is multiplying both sides of that equation by pi over 4. So that's pi over 4 multiplied by 180 divided by pi. We can simplify that by dividing out the pi's. 180 divided by 4 works out to be 45. So our answer here would be 45 degrees. Now if we're going from degrees back to radians, we simply do the opposite. We know that 1 degree is pi divided by 180 radians. And so we multiply 75 by pi over 180. So 75 degrees is going to be 75 times pi divided by 180 radians. Now again, you could compute that on your calculator, but we're more commonly going to want to leave radian measures when we can in terms of fractions of pi. 1 revolution is 2 pi radians, so it makes sense to think about revolutions in terms of measurements in terms of pi. So when we reduce that fraction, 75 divided by 180 reduces down to 5 over 12, so we get 5 pi over 12 radians. And we're going to prefer to leave our measures in that kind of form rather than getting a decimal that we would get on our calculator. It's just easier to interpret the fraction of pi because we know that 2 pi radians is 1 full rotation. So what about 6 pi radians? Well, again, we're going to use our radians to degrees formula. We know that 1 radian is 180 divided by pi degrees, so 6 pi radians is going to be 6 pi times 180 divided by pi degrees. Again, our pi's are going to go away. That's another reason why we like to leave the pi in our radian measures, is because we get exact answers, and that's going to work out to be 1080 degrees. Now finally, we want to convert 1/2 of a revolution to radians. Now we never had an official formula to go from revolutions to radians, but if we want to, we can go from revolutions to degrees and then from degrees to radians. So we know that 1/2 revolution is going to be half of 360 degrees. So that's 180 degrees. And then we know that 1 degree is pi over 180 radians. So that's going to be 180 times pi divided by 180 radians. And then the 180s divide out, and we just get pi radians. Another way we could have done that is by realizing that we did say that 1 revolution was 2 pi radians, so half of a revolution is half of 2 pi radians, which is another maybe easier way to get 2 pi radians. Okay, so what have we done in this video? We've talked about measuring angles using revolutions, using degrees, using radians. We also talked about arc length and why radian measure is useful for thinking about arc length. And we also did some practice problems converting between different units of angle measurement. In the next video, we're going to talk about trigonometry for real. So this series is called Crash Course Trigonometry, but we haven't actually really done any trigonometry yet. So we're going to start doing trigonometry specifically in a right triangle. As you may know, if you've studied this already, there's sort of 2 different ways to approach trigonometry, the unit circle and the right triangle. We're going to do the right triangle first, and then we'll circle back around, no pun intended there, but we'll come back around to the unit circle approach and then talk about how those 2 approaches are related. So we'll get through all that in this crash course. See you next time.